Hello, good morning, dear students. We are here again with the very interesting question number 7, year 2013. Year 2013, variant 1 2. It is about the kinematics graph and it is asking some analyzation of the graph, and we will see how to do. Okay, this graph shows a VT graph for a bungee jumper. Okay, velocity versus time graph of a bungee jumper, and it says at which point the bungee jumper is momentarily at rest, first point, and at which point does she have zero acceleration. Okay, so these 2 points you want to pick first. Okay, first of all, you know that this is here the velocity is increasing. Okay, and as soon as the graph goes down, it means when it touches the time axis, whenever it touches the time axis, the velocity becomes zero. Okay, so here is what the jumper is momentarily at rest. So here just mention that jumper is momentarily at rest whenever the graph touches x-axis. The graph touches x-axis. Okay, so clearly mention so that you know that whenever we are talking about rest of the jumper, it means that the graph goes down and touches x-axis, and the velocity here is zero. Okay, so you know that for the first step the jumper is touches x-axis at rest. It means we need to find out at which point the graph touches x-axis. So you know that this point at r, the jumper will be momentarily at rest. It means the velocity graph comes downwards and touches the time axis. It is point r. It means that we should have these two options: jumper at rest r and r. It means either C or D may be correct. Okay, so cancel these A and B. A and B is not correct because the jumper cannot be at rest at point Q. Okay, so Q cannot be the correct option. Okay, so now come towards the acceleration side, either Q or R. Okay, so here we know that from the VT graph I am just drawing a rough diagram. Here is V and here is time diagram. You know that is this and this. Okay, here we say the first part. On the first part, here we say that acceleration is increasing because the velocity is the linear graph of velocity and time means the acceleration is increasing. Okay, on this part, notice this part. Okay, because this lies here, our answer lies basically here. If we have this corner point initial velocity, and for this corner point we have final velocity. Okay, so here the initial and final velocity are zero. It means it means here the initial and final velocities are same. So therefore at this very part of the graph, of the VT graph, the acceleration is zero. Okay, so we need to find out, we need to relate this very point with this graph. Okay, we need to relate this point with the graph on the left. So they are asking that the jumper with zero acceleration, it means the graph top part. Okay, so where is the graph top part? Graph is going on the top here. If we gradient is basically a tangent line. Okay, so if we draw a tangent line here, so you can say that at very momentarily instantly at point Q, you can say that both velocities are same, initial and final velocities are same. So at this point, because the tangent is only horizontal at point Q, in other words you can say the tangent is only horizontal at point Q, because the tangent line in VT graph is always the acceleration. So here you can say the acceleration or the jumper acceleration is zero. So it means that at point Q the jumper acceleration is zero. It means that option C is correct. Hope you are getting my explanation. Option C is correct. Do not forget to like, subscribe in our channel so you can get more and more videos about A level physics and A level maths. Thank you.